Do a made-up example. Let's convert 5.2 pounds to ounces. And so we're beginning with 5.2 pounds. And the question is, how do I decide how to convert that? So from your little unit sheet, it says that 1 pound is 16 ounces. And what I'm saying is a very good way to do this, in a way that my sister does it, and the way that the book does it, so they never screw up, is to take that thing, which they're the same, and make what's called a unit fraction. The unit fraction is just taking one of the relations in the numerator and one in the denominator, and you'll use one or the other, depending on your situation. So the one on the left here would represent division. The one on the right would represent multiplication. And so for this example, I would want to use 16 ounces over 1 pound so I could cross-cancel the units of pounds. And it's a nice... What?
That's how you determine it.
That's how I determine it.
Okay.
One way I've shown this before, we used to do longer conversions like my sister does. I would bring in sticky notes, and we would put them down until the one that we wanted canceled. I think for these one-steppers, though, I just wanted to get everybody thinking about cancel the one that you wanted to go away and leave the one that you want. That's why I was stalling there. So this one is 5.2 times 60, which is 312. And the advantage here is it tells me 312 watts. It's 312 ounces that are left. And so I fit kind of the conversion that I wanted. So the top one I divided because it was in the denominator. So what I typed in on the top one was 40 divided by 16, which would represent something in the denominator. And when I typed in my calculator on this one was 5.2 times 16, because it was in the numerator.
So 83.2, yeah.
Oh, I just typed it in wrong?
Typing 60.
Oh, right.
We're all like, okay, we're not there.
So would it be easier to think of it as, if you have ounces, it's a smaller unit of measurement. If you're going into a bigger one, then you divide?
There's a whole other way to do this, just like that, where you make your decisions about multiplication and division about size. And I don't recommend it. I recommend doing unit fractions. The book recommends it. Your science teachers will recommend it, because you get a nice visual with practice on who cancels and where you're going. And it makes it really easy for my sister to do when a doctor gives her to do a drip and it's in a weird unit. That doesn't mean you can't do it, but you would get through this chapter just fine.
Okay. Yeah, because I'm still...
Let's try example 5.
Yeah, I'm still, like, what my question was, I don't know. How do you know which one to multiply, when to do the division one?
Okay. And that's just a understanding of fractions, really. A denominator is divide, a numerator is times. That's it. So when it's in the denominator, you divide it out. When it's in the numerator, you multiply it. It can help to do this.
The one that's not the answer. It's the one.
No, it's not for you.
I typed it in wrong. 5.2 times 16.
Oh, okay.
Let's try another one to get everybody on the page. Hopefully this one will help. So in example 5, it wants to us to convert 120 yards, and they want us to convert it to miles. So we start with your beginning value. Okay. We have something that your math book doesn't have. Hey everybody, even if you, everybody pay attention. Hello? On your handout that you should have, not everybody got one at the moment, but it says 1 mile is 1,760 yards. Everybody see that? Okay. 1 mile is 7,600.
But why don't we do the yard and the feet?
We'll do that again. So we'll do it like the book did as well. Is that what you're asking?
Well, yeah, because you don't have that many yards to make a mile, so when we use the yards to the feet.
So it said convert yards to miles. And so this would be your from yards to miles conversion. Yeah or no? These are harder than they sound. Okay. But
So you put that 1716 on the bottom.
here's your two choices. These are the possible unit fractions that you could use. You're saying which one would cancel?
The miles.
Which of these two?
I would, when you flip it, would you have to,
So I got
I know you got miles on top of it.
either way. Every conversion makes 2 unit fractions.
So 14.6 miles.
Fraction. Unit fraction.
14.6? What did you do, divided it?
Okay.
There's too much going on.
Shane, what do you
It's significantly easier than it sounds. You take this conversion, and the denominator should cause cancellation. So I want the yards to cancel.
Okay, on the bottom.
So I want the yards to go in the denominator.
So whatever the unit of measurement is, you want to have that as a denominator?
So it cancels. Like a fraction. So on a fraction, and now some of us are struggling because we don't see canceling as cross-canceling with fractions. Then you've got to go back and do some multiplication, but you put it so that it cancels, like cross-canceling in fractions, multiplication.
And then you divide that?
So that's where people are trying to decide, is that divide or multiply? Okay. I see it right away. I don't think everybody in this class has seen it, but if it's in the denominator, it's division. That's what the denominator is. It's just saying 1 divided by 1760. So that's definitely a division. So there's 2 skill sets here this is relying on. Cross-canceling, and then seeing that a denominator is division. So that is 120 divided by 1760. Which is fairly small. Okay, so if this one popped up on an exam, it'd have to give you a rounding digit, which, by the way, some people need some review as well. Let's suppose I said round to thousandths place. So my calculator is given 0.0681. So there's the thousandths place, it's the 8. It stays the same. Today's conversation, when we get to percents, running across the football field from 1 yard to the end to the other yard end, that's where the 120 yards comes from, is about 6.8% of running a full mile. We'll talk about that today. That's where we're heading today. Is that starting to look better? That you take your conversions and put them in such a way that you get cancellation for the English measurements? Okay. Okay. And in the book, they weren't as lucky as we were on that one. They only knew that there's 3 feet in 1 yard. And there's 5,280 feet in 1 mile. And it's just because they didn't have this nice little conversion that we do. You see that? This is not in the book. The 1,760 yards is not in the book anywhere. This will give you a feel for what my sister does when she's doing these major conversions, multi-step conversions. She can take these, make them into fractions in such a way that they'll cancel. Take this, make it into a fraction, in such a way that it'll cancel. So we did 2 steps. My yards canceled, my feet canceled, I'm left with miles. My conversion is correct if I put in my calculator.
What's on the top of the 5280? What is that?
One mile.
Oh, 1 mile.
And that's this conversion that the book had. They had that 1 mile. The book only has these 2 pieces of information. So the book couldn't do this nice single step conversion that we did. They had to do a multi-step conversion. The yards canceled, the feet canceled. And they're going to take the 120, or they're going to multiply or divide by 3.
Multiply.
Or they're going to multiply or divide by 280.
Divide.
So if they type in 120 times 3, divide by 5,280, lo and behold, they get the same decimal that we did. They left it as a fraction because they're assuming that you're not using your calculator like we are. So you'll notice that a little bit now that we've allowed the calculator, that the book still shows more steps. They don't really show the calculator steps. And that'll be particularly true in the percents chapter. They'll show you how to do stuff. I just want you plucking away at the calculator for the next 2 weeks to speed it up and just seriously make it easier. So let's do one more example. I had written down to do example 9. Page 451. So they want us to convert 105 minutes to hours. Maybe this would have been a better starting place, because I bet you've done a lot of conversions between minutes and hours in your past. And so if I got 105 minutes and I want it to be in hours, you probably know if you divide or multiply by 60. So in that one you have more, I think more people know how to do that one, that, hey, I divide. Well, for me, I want to show you that there's a way to know that you're dividing by 60 so you don't make a mistake when you're doing ones that you don't have that same level of understanding. Because not all of us know the units of yards and miles and pounds and tons and quarts and gallons is one that I don't even know very well. If you can put your knowledge from the sheet into a fraction in such a way that things cancel by cross cancellation, then I agree with you all for sure now that I'll divide by 60, because 60 is in the denominator. So I take 105 divided by 60, and I get 1.75 hours. The book gives the answer to that same problem as 1 3/4 hours. Or an hour and 45 minutes would be a way to answer that same problem. Okay. An hour and 45 minutes is more like dividing by hand and thinking of the remainder. I could use my calculator to get the 1 3/4 if I hit the fraction key. I took 105 fraction 60 and then I left it as a fraction. And then when I typed in 105 divided by 60, it gave me the decimal. So the fraction key would give it as a fraction. The decimal key is a decimal for divide. Questions on that one? You starting to see it, or you feel better about it with that one? Because you're more used to that one, so that one might help. Maybe good for the future. I'll start with that one. Okay, one last example. Maybe I'll start with this example in the future. How many days in a year?
Damn.
And there's always as mentioned, you can make it a decimal, you can go 365, 364, it's somewhere.
5 days a year.
Yep. And it's 364.25, and so sometimes they use the 24, the 25, the 0.25. That's right? It's not 365.25. No, that's right. Okay. That would cancel the years. And it didn't matter if you use 365 or 364 or the fraction. I haven't made a goal for this one yet. All right. How many hours in a day? How many minutes in an hour? How many seconds in a minute? This would be a way to tell how many seconds in a year. So you consistently can see that you got it correctly. You're left with that unit. Okay, so we're doing one steps, so we're not doing a multi-step like that, but I was hoping to give you a feel for that. I don't know if it helped. But in any case, try that all by Wednesday. Come to the Learning Center if you're struggling with it. And let's look at 5-4. But there is a reason why we want you to use unit fractions. It's to get that nice consistent so you can do longer problems in a science class without mixing them up. So if you did all divide and multiply and just thought through them, you'd probably be fine. But I'd like you to think about unit fractions. In 5-4, when we're doing metrics, Did I miss one? I missed the decameter. When we're doing metrics, they made your life easy. If we lived in a metric world, I would say you better memorize that. Since we don't, I threw it on the sheet here. Alright, careful not to do what I did, which is mark it up so bad that I can't read it anymore. Alright, but you'll get a nice new sheet for the final with this on it, because we're not as used to the metric world. And the great thing about the metric world, what do the M's stand for? And that measures what kind of thing? Distance. And if we want to measure volume in the metric world, we change to what? The base word is liters, but she said milliliters because that's the one we use the most. So in the volume world, it's liters. And in the weight world, it's... And you're used to hearing kilograms the most, and kilograms would be right there. You're used to hearing milliliters the most. Milliliters would be right there. Here's the great thing about the decimal world. Once you know how to do something in the weight world, all you do is change the root word, and you know how to do something in the distant world. So they're all consistent. And then you guys just know some of you're more likely to have heard about kilograms, and you're more likely to have heard about milliliters, but the base word is liters, grams, and meters. Those are the base words. Not a good start? You kind of seen it? Okay, don't need to memorize it, but notice I only gave you the meters on your little cheat sheet you'll get, but I'll be asking you to convert grams and liters, and you just change the base letter for those conversions. Does that make sense? Okay. Everybody will have one of these in the final. Everybody should theoretically have one right now. I've just run out of them. Just a little side conversation. On page 456 at the start of the chapter, since we're not used to... That's kind of weird looking. Since we're not used to them, they give you the distance ones in a way to think about them. So a kilometer is about a car-long train. That's probably a fairly typical size train. There's a kilometer. Does anybody know if a kilometer is longer or shorter than a mile? Shorter, actually. Yeah, but your numbers end up being bigger. A meter is about the door handle's height. A centimeter, for a lot of us, it's our pinky finger. You might actually put your pinky finger on the metric thing over here. No, that's not a pinky finger size, Shane. Pretty close. Actually, mine's exactly. If I go from my nails, mine's about as precise as you're going to get. Some of yours are smaller or bigger. And then finally, this is a good one. A millimeter is the thickness of a dime. I was actually trying this out to show somebody the other day, and I tried to use pennies. Pennies are way bigger than dimes, it turns out. It's a dime, and that's important. The dime's the narrow one. Millimeters are pretty small. So it's just good to know that. You will not be asked anything about that. The old book used to do these things. It'd say, if I was measuring the distance from here to Eugene, Should I use kilometers, meters, centimeters, and millimeters? Kilometers to go to Eugene. If I was measuring the distance from here to my office, kilometers works though. Meters would be the most likely. I'd say it's about 100 meters and maybe a little bit more, so it's about a football field to my office. If I was measuring the length of a pen, I'd go with centimeters, right? And then finally, if I was measuring the width of a pamphlet, millimeters. The old book used to ask those. I didn't see much of that in your homework, so I probably won't be asking that. I'll be asking conversions, and thank God they're quite a bit easier than the conversions we were just doing. So if I do example number 6 is what I said in my notes. Which was on page 462. Convert for 7.86 kilograms to grams. Especially for those of us that don't use the metric system a whole lot, I would recommend if I end up in a science class doing this, that I find this information. And it's really important to do this. You'll notice that all of them in the book have the information from the largest on the left to the smallest on the right. Okay, I'm not going to write them down each time, but all I had to do on my little handout that I've mixed up is put the grams. And so for this one, we're starting at 7.86 kilograms. We're going how many steps? So 1, 2, 3. You see that to get to the grams? So it's kilo, HM, DAG, and G. 1, 2, 3 steps to the right. What do we do with the decimal?
Move it 3 spaces to the left and to the right.
Do the same with the decimal. If you've written it from largest to smallest, the consistent, and not everybody learned it this way. I didn't either. So I always had to flip them because usually they're written backwards. So the book suggestion, I like it. They say right from the largest to the smallest, your units, so that when you do your move from kilograms to grams, you go the same way that your decimal is going to roll.
We got the grams and always gets it.
So 1, 2, 3. It's 7,860 grams. So it was measured in a big thing, kilograms. Now it's measured in a smaller thing, grams, in which we have more of them. Does that make sense? Okay.
Well, it's after grams.
Which unit is? It's a decigram.
A decigram?
Mm-hmm. Yeah, the question up here is what do all the names mean? In the book, if you look on each of the pages, we're used to using kilograms. I've never used hecto or decagrams. I just know that they're spaces on the move. I've used grams. I've never used decigrams or centigrams, but I have used milligrams. Here, why don't you try one? Let's have you, that's the starting place?
Yeah.
So I'm going to use two methods to do this conversion. I'll call the first one the shortcut. And then I'll do unit analysis with the unit fraction. So it really is a shortcut to use this thing. So one of the questions that came up as I was walking around was one of the questions that came up is this is in m's, meters. How do I get the same thing to do with liters? And I didn't explain that very well. I think you just drop these down and what letter changes? The M, which stood for meters, changes to L, which stands for liters. And that's what I was trying to say, but not super clear, I guess, here, was that the base words are all that change. You can use that same base formula. Alright, so the meters drops down, becomes liters, or grams. They're totally interchangeable in metric. That's why the metric is easier and better than our current system. So the real question said, convert 6 liters to milliliters. Do you agree with that now? Come through it? So on here, I got 6 L's, that's an L now, and I'm going to millimeters, or milliliters. How many spaces did I move? So that's 3 spaces. Everybody see those 3 spaces? So we go from L to DL to CL to ML, which is 3 spaces. What do I do with my decimal? Where is my decimal to begin with? So you gotta do your implied decimal. So you get 6,000 milliliters. The other way to do the same problem is with the unit fraction. If we lived in the decimal world, you wouldn't even probably ever learn about unit fractions. You'd just learn about moving your decimals back and forth and forget unit fractions. But one student noticed that on your conversion sheet, it says that 1 millimeter is 0.001 liters. Okay. There's also another conversation up higher that you could use as well. But they said, hey, what about that one? So they had 6 liters. And that one that we just read off said that 1 milliliter is 0.001 liters. I wouldn't have known whether to multiply or divide on that one at all, because I don't have the same intuition on metric. But if I made a unit fraction with it, it's saying take 6 divided by .001, and I get 6,000, just the same. Okay, using the unit fraction. Which would you rather do? Move the decimal the same number of places as a little formula, or make a unit fraction? With metrics, it's a whole lot easier, I think, to move the decimal. So I think I better give you another one. So, let's have you if we buy 12 bottles of wine at 750 milliliters each, how many liters would that be? As I'm giving back the second exam, you're a little stressed, and I should write out more stuff on these. Okay, so we'll put a few more notes here. But once you do some practice, you won't find this very hard. Once you get some practice in. If I have 12 bottles at 750 milliliters, where do I start with those two things? Which is 9,000 what?
No, milliliters.
We haven't done our conversion yet. There's 9,000, and I mean 750. I think I got it out of the book as typical. This one's 591. All right, so there's 591 in here. 750 is just a bigger. It's about a wine bottle size. And I think that's right according to the book. So now we got 9,000 milliliters. I'll write down more directions, but I was hoping that you'd see right away. There's milliliters. I want to go to liters. How many places do I need to move? So it's 1, 2, 3 spaces to the left. And what do I do with the decimal? 1, 2, 3 spaces to the left. Making 9 liters.
And then if you did the fraction one, you have to put the milliliters under the liter, well, the 1 liter.
So if you took the 9,000 milliliters and wanted to use the fraction that I had circled here, I would want the milliliters to cancel on that. So would you multiply or divide by .001? Because it's in the numerator, we'll multiply it. 9,000 times .001 is also going to give me 9. So you can use the unit fractions or the other. Okay. Why don't you go ahead and head on to this? So first of all, English measurements. Not so nice. With a lot of those measurements, some of you know, based on size, as Eddie was saying, when you should multiply or divide. I highly recommend, and so does the book, and so do your science teachers, that you start working on this thing called a unit fraction. It might not be necessary here. It really, really helps if you start practicing on the one-step ones. And I was trying to show you that, but it didn't come through very well today, that when you were converting years into seconds, or my sister's doing cubic meters per second into drops per minute for IVs, she wants to be nice and consistent. There's a reason to learn unit fractions. This might not be good examples. I'm not going to ask anything harder than these. All right? These are kind of the samples that we're looking at. And the idea is the units that 12 inches equals 1 foot, if I were to write it as a fraction because they're the same, that's just the number 1. That's why they're called unit fractions. That the numerator and denominator are the same. 12 inches divided by 1 foot is just 1. 1 foot divided by 12 inches is just 1. I don't think about it at that level. What I think about on this, if I want to convert 65 inches, you're trying to do something with 65, and so I write down my beginning value. And if I want to convert 3.4 feet, same thing, I'm going to write down my beginning value. This fraction represents multiplying by 12, and this fraction represents dividing by 12. The reason I think you know this, it's just stressed today. If I have 12 in the numerator, I'm multiplying. And if I have 12 in the denominator below 1, I'm dividing. Alright, so this would be dividing by 12, and that would be multiplying by 12. And the thing with the unit fractions is if I screw up accidentally, damn it, I screwed up, I'll know it. How do I know I screwed up on that? I can't cross cancel. So I get this visual on whether things went good or bad. That one was an oops, and I got to try again. And I try the reciprocal or the flipped, and I feel pretty good this time because they cross cancel. On this example, I want to divide by 12. And so 65 divided by 12. And what I try to do on exams when they're calculator is give you a rounding digit. On these examples, I don't always know that they're going to need to be rounded. So let's say the 10th place on that one. Did I type it in right? Yeah.
No, you're fine.
Yeah, I said 5 feet 5 inches gives about 5.
Yeah, that's a different conversation entirely. I want you to just say 5.4. Or the hundredths, it didn't say. And then I'll change the point inches. That's the conversation for a different day. And 3.4 feet, I want to make a decision about which unit fraction to put there. What do I want to have cancel? Feet. So I put 12 inches over 1 foot to get the feet to cancel. So you can see a whole bunch more examples like this in the book, but I'd like you to work on doing it with unit fractions, so do these conversions with unit fractions, even if they seem like they make the one-steppers a little harder. And so 3.4 times 12. It might help some of you, maybe this is the issue, if you make the whole number into fractions so you can see the multiply across. And if that helps you, I made the original into a fraction to help me see it. That's 40.8 inches. And as I've shown earlier with the metrics, you can totally use the unit fractions. And in that little handout that you'll get on the final, it even provides a bunch of the unit fraction information. Yeah, I don't know. But I would find it easier to use this stuff, which will also be provided. So, now what, Jackson?
What is your
2-year, beginning and starting unit, move to your
Starting unit, and then move to your goal unit.
Begin at your starting unit, move to your goal unit. The decimal moves to the same number of places. That's what you're trying to, I was just trying to see what to translate. Yeah, so that's supposed to say begin at your starting unit, move to your goal unit, the decimal moves the same number of places. And so I tried to explain, but didn't very well, that meters, liters, and grams are just symmetric across these. They change which letters there. And so it's really, maybe I should redo this thing and put all three versions there, but I'm not going to, because I'd like you to know this, that they're symmetric. And so if I'm asked to convert $437.4 centimeters to meters, I start at my starting unit and I move to my goal. Where's my goal at?
No, to the left.
I move. So start. Which way am I moving?
The left.
I move to the left 2 places. Which is, this is my handwriting more than your writing. So the reason to write them from big to small, which isn't normally how we would do something like this, is so that your move is precisely the same way. When I learned it, we wrote them the order that you would expect, and I had to do this little flip-flop of it was always the opposite order, so I did get it mixed up when I first learned this. I think this is the way to go. I like the book's consistency. If you write this, now mind you, you can ignore the word memorize wherever it said it, because I'm giving it to you. But in a science class, you may not be so lucky. So in a science class, you'd work on memorizing that. So that's all I'm going to talk, unfortunately, about 5, 3, and 4. But on Wednesday, bring your homework. I'll answer questions. All right, hopefully I'll remember to spell this out a little better next time. I haven't taught this in a while. I hardly ever, out of the old book, got enough time to teach it, but I think it's an important section. So, I have taught, on the other hand, percents a whole bunch. Does anybody know what percent means?
Times per 100 or numbers. It goes into parts per 100 or how does it go?
Any of these? I'm hearing lots of good ones. Parts per 100. Out of 100. That kind of statement.